afternoon, and welcome to Sadler's webinar on the Standards for Mathematical Practice in a Language We All Understand. My name is Janine Ferrara, and I'm the Director of Product Management for all Sadler's math and digital products. Today we're going to look at Sadler's new Common Core Progress supplemental program while I familiarize you with the Standards for Mathematical Practice. So what I'm going to do is walk through each of the Standards for Mathematical Practice and show you samples from our program on how each of these standards are implemented in the program. But before I begin, I just want to let you know that your microphones are on mute, meaning you can hear me, but I cannot hear you. So should you have any questions throughout the presentation, I'd appreciate it if you would put them in the chat box, and I will address them at the end of the presentation. So let's begin. Common Core. There are actually three entities of Common Core, and it's just not about the Common Core content standards. And everybody's familiar with the standards. That's what we look at, and we looked at immediately, I should say, when the standards were released on June 2nd, 2010. We would go to our grade level and look, what did Common Core add to our grade level? What did they remove to our grade level? And we know that there have been shifts in content with the content standards. But in addition to the content standards, Common Core has added process standards called Standards for Mathematical Practice. And these standards are what students should be thinking and doing when learning mathematics, and this is what we're going to be focusing on today. And then in order to effectively implement Common Core, there needs to be some shifts in the classroom. And this is how Common Cores are defined: focus, coherence, and rigor. Focus meaning that the United States curriculum was criticized as being a mile wide and an inch deep. So with Common Core, they want us to focus on fewer standards at each grade level and go into more depth of knowledge of topics, I should say, at each grade level. So to effectively implement Common Core, all three of these entities should be happening at the same time. And so it's not only about the content standards, but it's also about implementing the practice standards when teaching the standards, which are going to drive, I should say, the teaching of the content standards, as well as the shifts in mathematics. So just know that the three entities of Common Core should be happening all at once together to effectively implement Common Core. But today we're going to be focusing on the Standards for Mathematical Practice. And there are 8 of them, and they are common K through 12, which is nice. They don't change from one grade level to the next, but how they do change is the complexity of the content in each grade level. And they're not meant to be seen as a checklist where one day I'm going to be focusing on making sense of problems, and the next day I'm going to be modeling with mathematics, and the following day attending to precision. Yet you will be addressing a cluster of these standards when teaching mathematics every day. So you might not address all 8 of them, but you will address a cluster of them when teaching mathematics. And you'll find that standards 1 and 6 are pretty much the most important ones of the 8, and you will probably be addressing standards MP1 and MP6 every day, because we want students to be making sense of problems and attending to precision when solving problems. And we'll get into what each of those mean when I walk through the 8 standards for mathematical practices. And then before we begin, just think about while we're walking through the 8 standards of mathematical practice, what Common Core looks like in the math classroom. And the standards for mathematical practices are going to help ensure that students are collaborating, that they're conceptualizing, and that they're explaining and justifying. What Common Core wants is no longer for students to, for a math classroom, I should say, to be quiet or not active. They want students to be actively involved in the learning process, where they're talking and communicating and collaborating about math, and that they're conceptualizing math by showing multiple representations, maybe the concrete presentation, and as well as being able to support their conclusions by explaining and justifying their solutions with drawings, with words, with diagrams, with pictures. So the Common Core classroom, Common Core, I should say, is changing the way the classroom looks. So in order for students to collaborate, conceptualize, reason, explain. We need to engage them in the learning process. And one way to engage them in the learning process is to discuss with them what the content standards are about, discuss with them the standards for mathematical practice, and know that those are the standards that students are going to be held accountable for. That the standards for mathematical practice, I should say, are not teacher standards. They're actually standards that students are going to be held accountable for. And we should make them aware of what they are and familiarize them with the language and the expectations of the standards for mathematical practice, as well as the content standards. And one strategy that we could use to engage students in the learning process is called the SWOBOT strategy. And that stands for students will be able to, where the objective of the lesson is clearly identified for students at the beginning of math class. And the teaching channel, theteachingchannel.org is the URL for it, has a wonderful video that really explains the SWOBOT strategy in under about a minute. And I thought it would be nice to show you this video because they do a really great job of explaining how the SWOBOT strategy could be used to engage students in the learning process, and so that we can identify for them the content standards as well as the mathematical practice standards that they're being held accountable for. So let's just listen to this video. Sorry about that. Before I move on to the practice standards.
SWOBOT. So this is something that has been just really effective in our classroom. We have on our whiteboard a box that says SWOBOT. SWOBOT, 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 SWOBOT. Students will be able to capitalize, proper noun. SWOBOT. SWOBOT stands for students will be able to. And it states what our objective or our learning goal is for a particular lesson. SWOBOT. I will say and write the objective, and students will repeat it. Identify. It sort of has a rhythmic tone to it. It just signals to students' brains, okay, this is our goal for the next 15, 30, 45 minutes. What do I capitalize? The more we can be transparent with students, the more we model metacognition and we get them thinking about their own thinking and learning, we also help them become more effective.
So the SWOBOT strategy, I actually like the chant part of it because I know I've talked to a lot of teachers and they use the SWOBOT strategy in their lesson plans. They actually write what students will be able to learn as part of the lesson plan. But I do like the chant aspect of this strategy because it does help students understand what they're being held accountable for. So as I gave you a sneak peek of this before I played the video, one way that we let students know what they are being, what content I should say they will be learning is in the table of contents. Every lesson is clearly identified with the Common Core standards. So the students know which standards that they'll be focusing on as well as being held accountable for. And then at each lesson, the beginning of each lesson, we identify the Common Core state standard at point of use right at the beginning of the lesson. And in the Teacher's Edition, we identify the Common Core focus, so we spell out the Common Core state standard exactly how it is stated. And we provide an objective that can be relayed to students so again, that they know what they're being held accountable for. And then every unit begins with a progress check. This progress check helps students understand how all the standards are built upon one another, how the coherence in the standards, how they are connected across the grade levels. So it identifies for them what prerequisite skills do they need to come into the grade level with, what standards will they be learning at that particular grade level, and where those skills will be applied in the next grade level. So again, our progress check at the beginning of every unit demonstrates the coherence in these standards. And again, this is nice. It's not only for the teacher to know, but as well as the student. So again, every unit begins with a progress check. So as we begin, we'll begin with the practice standard number 1, make sense of problems and persevere in solving problems. What Common Core would like is that for the 4 problem-solving steps, read, plan, solve, and check, is for these 4 steps to become a habit of mind for students. As adults, we actually go through this process normally without hesitation because it's a habit of mind for us. We're not slowing down and saying, let me read that problem carefully, let me plan an entry point into how to solve the problem, and let me solve the problem accurately and check to make sense that it makes sense in the context of the problem. What Common Core wants students to do when given a problem, Common Core wants students to say, I can make a plan, I can make sense of the problem, I can make a plan, I can carry out my plan, and I can check my understanding. So we want these 4 problem-solving steps to become a habit of mind for students, and to make sure that they follow these 4 steps whenever they're faced with a problem, whether it be within the math class or in the real world. And another part of Common Core is that Common Core wants problem-solving to be embedded in the teaching of every standard and not taught as an isolated topic. So within our program, at the back of our book, we have what we call a Foundational Skills Handbook. And part of the Foundational Skills Handbook includes the problem-solving model, where we familiarize students with the 4 steps and provide them with mini lessons on how to apply the 4 standards so that they can gain a deeper understanding of the standards. And the reason why we do this is because problem-solving, again, is not a separate entity of the program, but integrated for teaching the standards. And one way that we teach our standards in our program is through a series of understand, connect instructional models, where we take the Common Core content standards and we break it down into chunks of content, if you would, so that you can hone in on a particular skill or concept within that standard. So every understand and connect presentation is taught through real-world problems, where we introduce every skill with a real-world problem, again, connecting the skill and the content to students' real world as we can make it for students. And then how do we need to encourage students to make sense of problems and persevere in solving them. So how do we do that? How do we encourage students to make sense of problems? Well, one way is to model for students how you made sense of a problem. And I recall that I just actually had my niece over this past weekend, and she needed help with elapsed time. And I had to help her, I modeled for her how I calculated and I determined the elapsed time, and then she was able to understand what I was expecting of her and how to solve a problem with elapsed time. So modeling your thinking process for students really helps them make sense of making sense of a problem. And ask students to describe the problem in their own words. If we ask students to describe the problem in their own words, then we know that they have conceptualized, not conceptualized, they really understand, I should say, what the problem is asking, what the question is asking. And then the third bullet point here I really like, because asking students to identify what they know that is not clearly stated in the problem, having students identify hidden information is very difficult. So asking them, how did you know that was a given, a known, a fact of the problem? Again, help students make sense of the problem. And we always want to encourage students to make a drawing, a table, or a picture, so again, to help make sure that they understand what the question is asking for. Number 2 is reason abstractly and quantitatively. And here's where you'll find language in the Common Core about decontextualizing, contextualizing. And here's where we want students to be able to move from a real-life situation and to the mathematics and back to the context of the problem. So what I mean by that is here, for example, we are talking about pencils and the distributive property. And we need students to be able to make sense of the quantities in the problem. So students really need to understand, make sense of the quantity 6, and know that 6 is composed of can be composed many different ways, and 2 and 4 is just one way that students can make 6. So make sense of the quantities, and now put that understanding back into the context of the problem in order to solve it. So making sense of quantities is a big aspect of reason abstractly and quantitatively. We want students to be able to move from numbers to words, the contextualizing, and then decontextualizing from words to numbers. So we want students to use numbers and words and reasoning habits to help also make sense of the problem. So how do we encourage students to reason abstractly and quantitatively? We want to ask them, what do the numbers used in the problem represent? What's the relationship of the quantities? How is one number related to another, one aspect of the problem related to another? So again, these are really thought-provoking questions that we can start to ask students to help them reason abstractly and quantitatively. Number 3 is construct viable arguments and critique the reasoning of others. And here's where we want students to really consider the reasoning of others. Can they explain their own mathematical thinking and then consider the mathematical thinking of others? So we want them to reason and explain their thinking. So at the beginning of every unit in our Common Core Progress program is a unit opener. And the unit opener begins with an essential question which sets the focus of the lesson, of the unit, I should say. And the essential question is one way that students, we can address MP2 and 3, where students are reasoning and explaining and sharing their ideas. We want students to learn from one another because there's research out there that states that students just learn best from their peers. They put it in a language that they understand. So having students reason and explain the essential question gives us one opportunity at the beginning of the unit. And then every lesson begins with an essential question, which builds knowledge to answer the unit essential question. Again, addressing MP2 and 3, asking students to reason and explain and share their ideas. And throughout the program, you'll see this little pencil icon, which just signals that it is an opportunity for students to write about mathematics and talk about mathematics, and which helps you understand students' thinking process. So I know you have many students in your class, and to make sure that students really understand a skill or concept, by just having them answer a question with the solution does not help you understand, to know whether or not students really understand the thinking process, that they really, whether students, understand the skill or concept. So if the answer is 3, we don't know that students really understand to multiply or divide. We really need for them to explain their thinking. And then in the guided practice section of every lesson is a think, pair, share feature. Again, we want students to really think independently first and then work with a partner or a small group to share their ideas and share their strategies. So in the guided instruction section, there are many opportunities for students to explain their thinking, as well as in the guided practice section and the independent practice section. So every lesson follows the gradual release of responsibility model that I do, we do, and you do independently. That's our guided instruction, our guided practice, and our independent practice section. And in our independent practice section, you'll see many exercises that ask students to justify their answers using words or drawings or numbers or symbols. And there is a difference between explaining and justifying. Explain is what you did procedurally, and justify is why it works mathematically. And we want our students to both explain and justify. So for example, if I was to ask you how you would compute 3 divided by 1/5, most people would say, I flipped 1/5 and multiplied 3 times 5 to get 15, so 3 divided by 1/5 is 15. And that's a perfectly reasonable explanation of what you did procedurally. And we want students to get to this shortcut to divide a whole number by a fraction. But we want them to be able to get to the shortcut only after they've conceptualized and they really know why, they've really, I should say, connected their answer to the meaning of operations. So a common core explanation would be tying it back to the meaning of division, where I know that I have the number in all, which is 3, and I want to divide it into equal parts of 1/5 each. So I know there are 5 1/5 in one whole. I have 3 wholes, right, the number in all, and I know that I have 5 of them. So I multiplied and go back to the meaning of multiplication with the number of groups and the number in each group. I have 3 groups, and I have 5 1/5 in each group. So 3 times 5 is 15. So there are 15 1/5 and 3. So that's more of that deep understanding, that conceptual understanding, that justification that Common Core wants our students to explain. So we have the explain part, which is fine, why it works what you did procedurally, but we want students to really explain what they did, why it works mathematically, and that's really important because we want to be able to push students' comprehension levels up the depth of knowledge chart. We want them to start thinking strategically. And we know that we have to have a really good mix of level 1s, 2s, and 3s type problems for students to really understand math. And we'll start with our level 1s and our level 2s, but we really want to push them to that strategic thinking, that level 3. So maybe they are just computing 3 divided by 1/5, and that's that recall. We want them to get to that recall, rapid recall, only after they've conceptualized. And so we want to ask that explain and that justifying step so that they can get to that strategic thinking level. Every unit in Common Core Progress ends with a Common Core review and a unit performance task. And the Common Core review reviews the Common Core state standards taught within that particular unit, and every item is correlated to a depth of knowledge level. And you'll see that, again, we have a really good mix here of DOK 1s and 2s, and you're not seeing the 3s. They're further on in the Common Core review. But we do want to try and move them to that DOK 3 level. And then the performance task, the unit performance task reviews a cluster of Common Core standards taught within the unit, and here's where we're going to ask them to answer questions that are correlated to DOK 3 levels. So at the end of every unit, we have a Common Core review and we have a unit performance task. So how do we encourage students to construct viable arguments and critique the reasoning of others? Let's engage them in a discussion. Ask them, what do you think about what maybe Mary said? Do you agree, why or why not? And again, asking them to talk mathematically, communicate mathematically is really going to help you understand whether students really have conceptualized a skill or concept. We want them to make connections between their own thinking and others. So we want them comparing strategies, their strategies with others. So number 4 is model with mathematics. And so I actually have this website on my screen, and it's 101qs.com, and it stands for 101questions.com. And what this website does is every day it posts a real-world image and a video, and it asks educators to identify what's the first question that comes to mind when you see this image. So with Common Core, they want us to model mathematics. They want students to be able to model mathematics in the real world and make sure that they understand that math is relevant and it has application to the real world. So I actually posted this, put this website up and actually included a picture here. So to encourage you to go to this website and begin every math lesson with a real world image that brings the real world into your math classroom and makes the math relevant for students. So if I put this image up, I actually could think of many questions depending on the grade level that I teach and depending on the content that I'm teaching at that particular time. I can think of many questions. If I'm in the lower grades and maybe I'm in kindergarten, and I could talk about how many milk cartons are on the left, how many milk cartons are on the right. I can compare, are there more cartons on the left or more cartons on the left? In the upper grades, we could talk about quarts and gallons and possibly volume. So bringing the real world into the classroom, into the math class, is one of the goals of Common Core, so that students really know that that there is application in the real world to what they are learning. So again, as I mentioned before, every unit begins with a unit opener, but the unit openers are engaging and it models math in the real world. And that there are conversation starters in the Teacher's Edition to support each unit opener. And they provide suggestions and questions to help tap students' prior knowledge on the unit's content and the prerequisite skills to help them apply it to the real world. So this is one way that our program is modeling mathematics in the real world and helping students know that math is relevant in the real world. And then, as I mentioned earlier, all our understand presentations begin with a real world problem, and we often use models to introduce a skill or concept, and in this case we are using the number line. And here's another case where we're using a bar diagram to introduce skills or concepts. So it's important for students to not only model mathematics with pictorial representations, number lines, or bar diagrams, but also to model it in the real world and know that the real world, there is a real world application to mathematics. And we need students to be able to make connections between the concrete presentation, the pictorial representation, and the symbolic representation, because we know that's going to help them lead to fluency. And these are different ways that we can model mathematics. And showing multiple representations of a skill or concept helps students really understand a skill or a concept. And we know there are different learners. Some learners may not need the concrete presentation and really understand the skill or concept. Some may need the pictorial, and some can go right to the abstract. But we do need to make sure that we provide different representations of a skill or concept so we meet the needs of all learners. So how do we encourage our students to model with mathematics? Let's ask them to make a model to represent the problem. Maybe they need to write a number sentence or use symbols to represent what's happening. And number 5 is use the appropriate tools strategically. Think about tools, not only tangible tools, but non-tangible tools. And the tangible tools are obvious. We want students to know when to use a ruler, when to use a protractor, or when to, I should say, maybe know when to use an inch ruler or a centimeter ruler or a yardstick. We need students to make sure that they understand when to use those tangible objects. But we also need to make sure students understand how to use those non-tangible objects, the virtual manipulatives, problem-solving strategies. For students to choose the correct strategy to solve a problem, they're using the appropriate tools strategically, or a computational strategy. So those are important tools as well. And again, there's a number line showing we're using that tool as to teach a lesson. And I'm sorry I didn't have a different one, but here's a different one. We're using counters as a tool to solve this particular problem. So how do we encourage students to use the appropriate tools? Let's ask them, how did you use that particular tool to solve the problem? Was it helpful? And I really like the second bullet. If students didn't have access to that particular tool, and of course we're talking about a tangible object here, what other one would they have chosen? So these are really, again, nice thought-provoking questions that we can ask students to understand the standards for mathematical practice. This is number 5, I should say, MP5. And attending to precision, number 6, is multifaceted. So you'll see at the top of my screen I have vocabulary. And one aspect of attending to precision is we want students to use precise language when reasoning, when explaining, when communicating, and talking about math. And so we have a words to know feature that's clearly stated, that's identified at the beginning of every lesson. And the the key math vocabulary for the lesson is clearly identified, not only in that little math words to know box, but also it's highlighted on the page. And then there's additional support in the teacher's edition on the math vocabulary for the lesson. And then attending to precision also includes labeling graphs. We need students to attend to precision, making sure that their graphs are labeled correctly, that they include a title, that their axes are labeled, that the scale is labeled correctly. Because without any labeling, the graph has no mathematical meaning. So attending to precision by labeling graphs, tables, and diagrams is extremely important. And then including units. We need students to, when solving a problem, answer it in a complete sentence, including units. And we do this throughout our entire program. Every problem that's posed, we answer it in a complete sentence and include units. So the answer to this problem is just not 7. It's Grace waits 7 minutes for the bus. Minutes is extremely important. Those are the units that we want students to include. So we want students to get into the habit of mind of always including units beginning in kindergarten, whether they draw a little picture of the unit. Maybe it's 2 apples plus 3 apples, and the answer is 5 apples. And students draw that apple as the unit, or if they can, write the word. So again, including units, attending to precision, including units is extremely important. So you could see that attending to precision is multifaceted. It includes 3 parts. It includes your vocabulary, it includes your units, and as well as your labeling graphs. So how do we encourage our students to attend to precision? Let's ask them, what new words did we use today, and how did we use them? Again, we're getting students talking about math and sharing their ideas. So if you remember, we can go back to that diagram that we had at the beginning of the presentation where students were collaborating and explaining and justifying their answer. And number 7 is look for and make use of structure. And here's where we want students to understand that there is structure in our number system. There's in math. There's structure in our number system. There's structure in place value, I should say. There's structure in the algorithms. So we want them to be able to understand how numbers and shapes are organized and put together as parts and wholes. So here I'm showing on my screen at the lower grades where students are making 10, and they really need to understand how that concept of 10 is used to form larger numbers, that structure of larger numbers when we teach larger numbers in the upper grades, as well as when we get into the algorithms, the importance of making 10. So how do we encourage students to look for and make use of structure? Let's ask them how they can prove that their answer is right. Do they always see that 10 is made up of different ways? And can they find a rule or an equation that always works? And then number 8 is look for and express regularity and repeated reasoning. If it's regular, it's MP8. If it's repeated, it's MP8. If it's both regular and repeated, it's MP8. So we want students to learn. Students learn, I should say, through repetitive action, ways to find general methods and shortcuts. So that you'll see I'm just showing a patterning lesson in our Common Core Progress program, but we do help students see the shortcuts in getting to the algorithm, but only after we've gone through the concrete, pictorial, and abstract stage of teaching a lesson. So again, let's ask our students if they see patterns, if they can identify a shortcut, and is what they're working on, is it always true, sometimes true, or never true? So I've taken you through the 8 standards for mathematical practice, and I've taken you through each of them one at a time, but know again that you would be addressing a cluster of these standards when teaching mathematics. And I encourage you to engage students and parents in the learning process and help students identify, or help them identify what they're going to be held accountable for. So engage in a discussion every day about the practice standards. Which ones did they use today? Which ones are their favorite? Which ones are their least? I suggest that you post the practice standards around the classroom so that this language becomes a habit of mind for students. I know when I go into classrooms, I see a lot of wonderful math posters, fraction decimal equivalents, the problem-solving process, the 4-step problem-solving model. Let's post the 8 standards for mathematical practice so students become familiar with the language and start using it naturally, and it's a part of their learning process. So when I've taken you through the 8 standards for mathematical practices, I've talked to you about our Common Core Progress program, and I've shown you samples from our Common Core Progress student work text. But know that Common Core Progress is a comprehensive program for K through 8. It is a supplemental program that's not meant to take the place of a basal program. It's meant to complement any core program that you're currently using. There's a student work text, consumable K8, a teacher's edition with comprehensive teaching strategies at point of use to teach each lesson, free online resources in terms of fluency practice, additional practice for every standard, home family connect activities, unit performance tasks, all free online on Sadler's new learning platform called Sadler Connect. And then we have a web-based assessment system called iProgress Monitor, where all our program assessments, our Common Core reviews, our performance tasks, as well as our benchmark assessments, which I'll talk about in a second, are all available in an interactive format on through our iProgress Monitor web-based assessment system, as well as a test generator where you can customize or build your own assignments or assessments based on a particular Common Core standard, where students' assignments are automatically scored and graded and recorded for reporting purposes. So you could monitor and modify instruction based on student results. So our iProgress Monitor, boy, stumbling on that one, our iProgress Monitor system is a pretty robust assessment system that I think you'd find very useful. And then the last print component of the program is our Progress Monitor benchmark assessment booklet. So our Progress Monitor includes 4 benchmark assessments. Each of them assesses 100% of the Common Core standards. And the first benchmark I would suggest using as a diagnostic at the beginning of the year so you can gauge where students are, where students' skill sets are at the beginning of the year. And then benchmarks 2 and 3 would be used more as formative instruction to guide instruction throughout the year. And then benchmark 4 would be mostly used right before students are going to take those high-stakes end-of-year assessments, and it would act as a good predictor on how well students would do on the end-of-year assessments. So with that, I've taken you through the 8 standards for mathematical practice. I've talked to you about our Sadler's new Common Core Progress Supplemental Program. And if you'd like to request a sample, you can go to that URL that I have posted on the website so that you could see sample units of every grade level and we request samples for each grade. So with that, I'm going to open it to any questions that we might have. So one of the questions is this this webinar being recorded? So yes, this webinar is being recorded, and you will receive, when you receive a thank you from Sadler, you will receive a link to the recorded webinar, so that should you like to play it back for your colleagues, you could play it back for your colleagues to view. Next question is this program available now? Yes, the program is available now. Again, it's a K-8 program, though I apologize that I'm only showing 1/6 covers, but it's a K-8 program, and all our print components are available now, and our digital components will be available within the month, and then the iProgress Monitor will be available for back to school. The next question that I have is, what is the cost of the program? So the cost of the program depends on how many student editions you purchase, but with the, I believe it's 20 plus copies of the student edition, the cost is $14.95 per student work text, but I know that they are promoting a bundle, which you would get the benchmark assessment and the student work text for $1 more. So for $14.95, I believe, plus $1, for $15.95, you would be able to get the student work text and the benchmark assessment booklet. Well, I want to thank everybody for attending today's webinar. If I did not answer any of your questions, I definitely will get back to you via email, and I hope to see you on future Sadler webinars. And again, should you like to request a copy, there's the URL to go and request a copy and preview some sample units for every grade level. Thank you so much. Have a great day.